Okay, angular momentum before collision is just moment of inertia times angular velocity, right? For the first object, that's 4 kilogram meter squared times 4 radians per second times the k vector, added to the moment of inertia times the angular velocity of the second object, right? Which is the 0.07 kilogram meter squared multiplied by 3 radians per second times the vector that gives you the direction and changes the magnitude very slightly, okay? Okay, that's fairly close to a unit vector. Within potential round off it is. That's not particularly relevant. This is what it is. Whether this is a unit vector or not, whatever it is, it's what it is, right? So we just use the distributive law over here, and we've got this, but we multiply things out. 0.07 times 3 is 0.21. So for this one we get 0.21 kilogram meter squared per second times this vector, right? And this one is just 0.16 kilogram meter squared per second multiplied by the k vector. And we just collect our terms, and here's our angular momentum before collision, right? So after collision, the angular momentum is 0.04 kilogram meter squared plus 0.07 kilogram meter squared multiplied by omega f. Okay? And the two are equal, so we can easily solve for omega f, right? So this is equal to this, and we get omega f we get this. Here we have units of kilogram meter squared, which divide our kilogram meter squared here. We do have our second, and put a square on that second, because I'm just so used to writing that. But it's not squared. Kilogram meter squared per second, so the kilogram meter squared go out. We end up with a reciprocal second, and because of the way radians behave, as I explained before, this is going to be radians per second. Now you can do the arithmetic. You divide these by 0.11, and what do we get? We get something like 1.1 I plus 1.1 J plus 2.4 K radians per second. Okay? 1.1 I, 1.1 J added to 2.4 K, right? So vector about this long here, vector about this long here, added to vector about this long here, gives us a vector about like this. So things are going to be rotating in the plane perpendicular to this, in this plane. It was originally in this plane, it's now in this plane. And the mathematics tells you that, but of course by doing the mathematics and thinking about it, you develop some intuition, right? Hopefully. Still, in 3 dimensions, it's easy to calculate. There's nothing in that calculation, actually, that really goes beyond Algebra 1 if you just regard I, J, and K as unlike terms, okay? Just using the distributive law, collecting terms, doing the units, which might be a challenge, okay?